Let's now deal with the final piece of the puzzle, which is after defining the algorithm, after translating it into TLA plus specification, and let's now try to define some Boolean properties so that we can check invariance and also deadlock freedom. That's the final bit of the tutorial series for this lab. Let's take a look. So you remember this will be the start of the module. You want to go all the way to the end. You will see we go across the algorithm, and also we go across the part where it's automatically translated. Just make sure you don't really try to modify anything over here, even by mistake. No, right? Just make sure anytime if you believe you somehow messed around with it, you have to make sure you automatically generate or translate the algorithm again by clicking on the button. This will be the end of the translation over here. I would suggest hit a new line over here. You don't really define the property after line number 140 on my screen over here. It should be above, right? It should be between line number 140 and also line number 138. Should be in between. It must be after the TLA plus translated predicate. Okay. And what should we do? Let me put a comments over here. So what we want to do is add Boolean properties for checking, model checking, of course you can say. And let's now remind ourselves about the two invariant properties for M0, the initial model for the bridge controller. I'll leave them here, okay? So we got invariant 0_1. If you remember, 0 stands for the model 0, and 1 here is the first invariant and second invariant. Let's now define them right away. Okay, you just have to get familiar with the workflow of defining properties. So whatever you define over here, they will not reveal themselves. They will not be reflected immediately when you actually launch the TLC checker. You will have to add them up to the TLC checker manually. That's something I will show to you. Let's define them first. So you would say, first of all, we're gonna have the define as syntax. Oh, over here. We're gonna have the equal, the define as. On the left hand side, we put the name of the property. In this case, invariance for model 0_1, right? It's defined as n, which is variable, is a member of natural number. So you want to remember the syntax. And this will be some syntax you have to write. If there's only one predicate without any conjunction, in that case, you might just say n in net over here, right? If you actually got multiple conjunctions, you may have to put the conjunction syntax over here, like what we said in the earlier video. Let's try with this first. Alternatively, you can also do this if you want to. So having just a single conjunction over here, wow, I know it's a little bit confusing syntax, but just the way TLA plus is. If you only have this, it's as if there's no two operands for the conjunction. It's as if you just put n is a member of net. Okay, but let me just try with this first. Let's try to see. It should not really make any difference. I'll just say alternatively. Alternatively, you can say this and in net. Again, this symbol will only make a difference if you actually got a left operand, like this one here, right? You can think about this one over here. You really have the left operand PC equals and also right operand I prime equal to, right? We'll talk about how actually you can write the syntax in the previous part of the series. But if you only got one single line, it would be as if there was no conjunction symbol, right? It's just a specific detail you have to know for TLA plus tool. It's the design of the syntax that's beyond our control. We just have to learn and deal with it, right? And for invariant 0_2, oh, by the way, so for set membership, it's actually /n. Okay. Of course, you can find out also other operator, right? In the resources that was linked in your lab manual. Okay, we got some error over here. As soon as I save the file, that makes sense because I only got the left hand side for the is defined as. What about the right hand side? The right hand side should be n less than or equal to D, right? You can see over here. Let's see, n less than or equal to D. Very simple. So these two properties, well, as soon as I save, you can see the error goes away, which is nice. But again, as I said before, there are certain errors which may not be revealed as soon as you save the file, but you have to translate, you know, the TLA plus the Pascal algorithm. Okay. And then let's also now talk about at Boolean properties for, let me say, model checking of invariants. Right? So these two will be the invariants. And now here, let's talk about Deadlock freedom. For model checking, Deadlock freedom. Basically, Deadlock freedom itself may be treated as also like an invariant property. You want to say it is always the case that for every state, the disjunction of the event guards is always true, right? Basically, at least one event should be enabled. That's something we learned about in 3342. I'm going to write it down just to remind you. For our purpose, we're going to define the Deadlock freedom consistent with how you did it in 3342. A system being deadlock free. Being deadlock free means there is at least one event that's enabled, i.e., event will be able if its guard is actually true. Guard evaluates to true. All right. And the way to say there's at least one, so that means we're going to disjoin using the OR operator for all the event guard. In this case, what are the event guards? You can see ML, MLN. They are implicit for their guard being true. And you can also see, let me show you quickly. You can see from the Pascal program over here, we got true here and we got true over here. So we got to put true just for now, explicitly. And later on, if we find that we have the need to really fix the guard, then we can do it. Okay, let's try that. So what we'll do is we're going to say the guard of, let's say, ML out guard. And not label, but equal, right? It will be, in this case, just true. Oh, actually all capital. If it's not highlighted properly, you know that you didn't really spell it properly. ML and guard equal true, right? We define it separately, and let's now define what deadlock free really is. Okay. Deadlock free equals ML out guard or ML in guard. Okay, save it. I have some error over here. Let's take a look. Okay, over here it's saying that ML out guard. Oh, already defined. Okay, I see. Don't worry. The problem is not really about the syntax on the right hand side. I think it's a nice error which I didn't really plan. So you can see ML out guard really corresponds to the label that we defined earlier, if you can recall. Let me show to you. If you can see the ML out guard over here, right? So either we can change this label over here, or we can change the Boolean property name, ML out guard. I would suggest we don't really touch this ML out guard. Do you know why? Okay, it's actually very important for me to explain that once more, right? If we modify the ML out guard, the name over here, what does that mean? That means we are actually going to modify this part over here. And remember, whenever we modify this part over here, we have to translate this part over here, which will be, in this case, unnecessary, because we're only trying to add things over here. Whatever you add over here, if you are not really modifying the algorithm at the same time, there's no need for you to really modify over here. All right, it's really important. Let me write it down. It's actually the last point I would like to make. Let me move this model over here away. That's the last remark I would like to make about the structure over here. But now it will be the time to talk about it. Okay, I'll put it here. How about orange? Okay. Okay, so here, retranslation unnecessary. If number one, only, okay, how about this? Number one, the property part got modified. And when I say the property part, I mean this part over here, right? That's the property over here. If this part is modified, and number two, the algorithm part unchanged. Right? So if both are true, in that case, it will be unnecessary. In this case, if you're only modifying this part over here without modifying this part, it will not be necessary for you to retranslate the algorithm. But if you're modifying this part, of course, by definition, you have to translate to really generate the up-to-date TLA plus predicates, right? It's really important to reinforce this point, right? Right, let's go back. So what can we fix this? Let's go back to the label over here. Now we label the name of the Boolean property. Okay, rather than ML guard. Why don't we say ML out, let's say event guard. How about that, right? Just make a unique name. Okay, save. All right, everything's good. Awesome. I think, oh, of course, you want to make sure you really refer to the right thing over here, all right? So you want to say ML event guard, which is referring to the guarding condition. If you only put the ML guard over here, let me just copy and paste very quickly. If you only put ML guard, it's really referring to that execution point. So you're really defining something else. All right, ML event guard and ML end event guard. All right, everything is still fine. Save it. Make sure there's no star over here. So these are all the properties we will want to check, right? So let's now try to check the invariant property and deadlock freedom property. To do that, I would suggest we do one setup in order to visualize the state diagram at the same time. This will be some setup you will have to do manually. Let me show to you. First of all, go to the file over here. Okay, click on file over here and go to preferences. All right, and then on the search bar over here, search bar, you can type PDF. Right, click on PDF viewer, and then over here, it will be important for you to specify something. Okay, let me show you what to type. And this only is the path that will work for the remote labs scenario. Of course, during the programming test, this might be something you will have to do manually, but I'll include the instruction for you, so you don't need to memorize the path. But what if I type over here is really referring to the program for the graphics tool, which is also cross link in your lab menu. If you are installing your the TLA Plus tool on your machine, you have to change the path over here accordingly. In the case of the remote lab, it's going to be /cs/local/bin/dot. So this is the executable that we are using. It has been already installed on the remote lab environment, so we can just refer to this path. And again, this path only works for the remote lab, which is okay because you can always use a remote lab as a backup option for your lab and also for your programming test. Right? Just make sure you do this and then apply and close. This will be part one. Okay. And for part two, we are going to create new model. Okay. So it will be very important for you to really understand the following. Okay. So basically, we got our module done, right? Module contains the constant, axiom, extends, algorithm, and property, right? So we talk about two things. Okay. We talk about the module. Okay. We talk about the module, which contains mainly the algorithm. Let me say just the algorithm and the property. Algorithm, and also the property. And also you got other context kind of stuff, which includes, for example, the constant, right? And for algorithm, of course, the variables. And in order to model check these two, especially the constant over here, should be restricted. In order to be feasible for model checking. For the variables, of course, we already got initialization, so presumably, once the constant has been somehow restricted, the variables will be restricted as well. That's something you can kind of assume, right? And remember what constant we actually have for our module. We actually got, in this case, the D and also the bound, right? At the moment, you can see, if you go back to the context over here, let me show to you. You can see for these two, for the bound and also for D. So they are simply just natural number. One is a natural number, right? The other one is simply a positive integer. In that case, what will be the combinatorial values for these two? What would be very infinite, because you got so many combinations, right? If you want to think about all the possible combinations between a natural number and another positive integer, it's really too big to really consider. That's something we spoke about in the introductory part of the course. So in order to really make the model checking feasible, we have to give some specific value for us to check. As long as the value itself is big enough, you can be assured that the result can just be extrapolated into the larger value. Okay, so what we're doing over here is by creating a various model. You can create for as many as you like. So let me say, you can say, well, I want to instantiate this. Okay, sorry. I want to instantiate this into a model. Maybe for model, of course, I give a name. Let's say let's say model 1. Okay. In that case, I may set D to be 2, and also I can set maybe bound to be 2 as well. What does that mean? So in this particular instantiation, there can be only maximum 2 cards in the island bridge compound. And also, when we actually talk about system trace interleaving, there's only 2 events over here. There's a very small model, a very small instantiation. We can try to see within this restriction, can the invariant hold? Alternatively, we can definitely try to create a larger model over here. There's another instantiation. You can create as many as you like. I'll do one, and then I'll leave others to your exercise, right? That's really something you're expected to explore on your own, right? So over here, I got another model over here. You can say this is model or instantiation number 2. I can increase the size of D to be 4, and also the bound maybe to be 10. So that means we're talking about maximum 4 cards in the island bridge compound, and also we're talking about an interleaving trace with 1, 2, 3, 4, 5, 6, all the way to 10 events, right? It's a larger model. And if you really want to make sure the bridge controller can really work for a realistic system, you can definitely increase, for example, D to be maybe 1,000 or 10,000, and the bound over here to be maybe 1,000, something like that. You can definitely give it a try. But of course, at some point, if the D value and bound value are large enough, it might simply take the model checker much longer to terminate. It's it's unavoidable, because after all, model checking really try to explore the finite state system, the finite state diagram graph that you actually have for your system. The smaller the constant over here, the smaller the state diagram it is. I'll show you the state diagram in just a moment. We just need one more setup. We'll get there. But guys, it's really important for you to understand what we did earlier. Prior to this, we were just defining the general module over here with constant, and then we're gonna instantiate various model as we wish to really check the invariants with different setup to make to be feasible for model checking. Okay, that's something we're gonna do. Let me take D equal to 2 and bound equal to 2. Let me take that. Let's see how we can create that instantiation. To create a model, you can simply click on the models package over here and right click and say new model over here, and you're going to give a name. I would suggest keep the system generated name over here, model number 1. So 1 here is a very nice numeration to tell you which model you're creating. However, I would suggest also put some postfix over here just to be more informative. In here, we're going to restrict the value for both the D and also the bound. So we can say underscore D will be value 2, and also the bound is going to be value 2 as well. Of course, later on, when you create model number 2, later, you can simply just change the value over here when you actually increase the actual value for D and also the bound, right? This will be a very nice, informative way to really name your model. So when you look at the list of models or instantiations you have created, you can see right away which one you want to model check. Right, let's now click on OK over here. And one thing to note, the default option here, temporal formula, keep it over there. Don't really choose any other option. And also, this will be the top level spec. If you remember what we said before, the top level spec, right? Let's take a look over here. Spec. Exactly over here. So what we said before was really important for you to understand, to really appreciate how things have been set up for you, okay, automatically. Let's now go back over here. And then, really important for you to do, okay? You will see by default, under what to check, the deadlock over here has been checked already. Please uncheck it. So somehow the deadlock freedom check that's default by TLA plus toolset is not really exactly the same as the deadlock freedom that we just defined. That's consistent with 3342. There will be some scenario where it will make a difference, which means what we thought you should really pass as deadlock freedom, but it wouldn't pass by the TLA plus tool. I'll try to see if I can explain to you more precisely maybe later as we get more advanced. But for now, just make sure you always uncheck the deadlock over here, right? It's really important, uncheck deadlock always here. And under invariants over here, we're actually going to add the Boolean property that we want to check as invariant. I'm going to add 1 or 2 just for now, and then we'll work on that and see if there's anything we got to fix. And then the remaining part might just be left as exercise for you. But before we do that, before we hit on the button over here, right? Of course, every time you want to hit on the button here, you want to make sure there is at least some invariants over here. And later on, when we talk about temporal formula, maybe later in the later lab, we're going to add more formula over here. But for now, we're going to add something here. Before I do that, let me show you the setup you got to do so we can see some visualization of the state diagram. So it will be the state diagram specific to the D and also the bound, right? And before I do that, let's see here, you see 2 errors detected. So that one is saying provide a value for constant D. Oh, sorry, just read it. Provide a value for constant D and provide a value for constant bound, right? We got to restrict these 2 values in order for the model checking to be feasible. How do we do? D here and a bound over here. Double click on each one of them. Double click on the D, and all you got to do is put 2 over here. Don't worry too much about other like a model value, set of model value just yet. Let's just do ordinary assignment. Just restrict that to be just a single value. So we are only considering maximum 2 cars in the island and bridge. And double click on the bound over here and set it to be 2. So we're going to do an event trace for observation for just 2 events. So the while loop is only going to iterate for 2 times. It's a very small model to build and also to really model check. And that's really good as our first example. So I can show you all the functionality you're supposed to know. You're definitely expected to really create a much larger model and to explore and convince yourself everything's still working. All right, given this, let me now do the following, the setup. You will see that there is another, let's scroll down a little bit. Okay, scroll down. You can see there is a option here, additional TLC option. Okay, not this one here, additional spec, not that one. Okay, additional TLC option. Click on that, and then under features over here, right, you will see there is one checkbox over here. Visualize state graph after completion of model checking. So we want to say every time after we are done with our model checking process, we want to visualize the state diagram that was just checked by the model checking process, right? So this is a very nice way. Let's say if you really fail certain property, you can really know what graph was actually performed the check on. Sometimes the graph may not make sense to you, in which case you may have to go back to fix your model, right? And typically this generated graph for the states should be looked at side by side together with arrow counter trace. That's something we'll look at. Right, you can see there's a star over here. That means the model, the instantiation has been modified without being saved. Control S to save it, right? Right, let's go back here. So we have already set up the TLC additional option over here to really visualize the state diagram after model checking. It's really important for you to do this step, otherwise you wouldn't see the state diagram afterwards, right? And then under invariants over here, let's now check just one of them. Let's say add. Over here, the formula I just need to add will be, if you recall, back, okay, let me just show to you what you can put. You can put basically any of the Boolean property you declare in that section. You can either put this one here, you can put this one here, or you can also put Deadlock free over here. Of course, it wouldn't make sense to just put MLR event guard, right? Because it should be disjoint with other event guard, right? So this could be one, this could be one, and also this could be one, either one of them, right? Let's do invariant 01 first. So what I will do is I'm going to add a property over here for invariant checking. And make sure you spelled it right. Invariant 0_1, all right? And then you're gonna say finish, right? It's checked automatically. And later on, once you add a different invariant over here, I'll let you add another one, and also we can do Deadlock free then as well. We'll do that later. Just make sure the one you want to check really has to be really checked for the checkbox over here. Now everything's ready. Let's now try to hit on running the TLC checker for invariant checking. All right, it's running here. It's a very small model, so it wouldn't take too long. And what we have is over here, if you look at this, well, we got one error over here. And the error is actually under error trace over here, right? Error trace over here. So it will be very important for you to actually look at this error trace, right? So every time, let me just write down the principle you should really follow. And then try to use this scenario as an example. And then I'll give you some direction about finishing this little M0, and then you can go ahead to do other problems that are assigned to you for this lab. Right, you got a state graph over here. So what I will do is, this state graph here, I'm going to look at that together with you closely. But where can you find this PDF? Very easy, I'll show to you. Go under activities and go to show applications, and you want to search for the file browser. Right, go to files. And if you remember, let's see over here. Maybe I already opened that, I guess. Okay, it's already opened. Click on that. And then remember where the workspace is, depending on your setup. In my case, I store that under the desktop. And go to 4315. And then remember the .toolbox. So these will store certain files that's in addition to the module file. So the state graph is one of them that you may just want to get access to. Click on that. You will see under, you can see model 1, D2, bound 2. If you go there, you will see the diagram over here, right? If you click on that, that's the PDF over here. Very nice over here. You can definitely save it if you need it, just for your reference, right? But I'm gonna look at that partially and then try to explain to you how to understand it. Okay. Before that, let me just go back to the TLA plus over here. Okay, let's now go back to the TLA plus over here, and oh, am I already there? Okay, let's close it. Cannot be locked. Okay, sure. I guess because both the PDF viewer here and the TLA plus 2 are opening the same file at the same time, so that's why it's showing me that error. Let me just close it. Okay, and just remember, this is how you can find the PDF file for the state graph. That's my main point. So what I'm going to do now is I'm going to show to you why the model check actually failed, right? You can remember the result over here under this tab here. It says one error. If you didn't see any error, so that's good. That means the invariant property that we just checked, which was about the, okay, let me go back over here. So which was about the, if you go back to model overview, the invariant 01 being true. but apparently it's not the case. So that's why when you go under the checking result over here, you have to debug yourself. This is a very important technique for you to really go through with me. So we're going to look at the state graph and the error trace side by side, and then we're going to decide if there's anything we can do to fix the model so that the property can be successfully checked.